Hi everyone, so this is going to be the Canopy video on using Rhino inside Revit to create columns and beams in Grasshopper and send them over to uh, Revit. So I'm going to do a new model, do metric. As I said earlier, the units that you open Rhino with will be whatever the units are at the time. So you can kind of set them in Revit first. First thing to do always is sort of check what units you're in. I'm going to set this to meters as it makes everything much simpler for this kind of communication process. And I'm also going to open a 3D view, which already exists by default. And I might actually, as well, in my units, give in the length meters and 2 decimal places, so it doesn't just round up to 2, 3, 4 meters. And now this is really, really important. I deliberately did not start this video with Rhino inside open, but you cannot open Rhino from here. So you cannot do this. You cannot open Rhino from Citrix directly. That's not going to work. Rhino has to be opened from within Revit. So within Revit, you go to Rhino inside and hit start. And this is more like a power button. It's just going to power up Rhino. Usually the window doesn't actually open until I click on this Rhino here and then this Grasshopper here. Or you can, from within Rhino, open Grasshopper the usual way once it's this version of Rhino, the one that's sort of within Revit. There's a speckle connection issue. That's fine. You'll probably have this exact same one. So now I can hit Rhino to open the Rhino window. Put that over here. And turn off the sidebars. And zoom in on the perspective view. And then these will be grayed out because I currently have the Rhino sort of selected and not the Revit. So if I just click here once, now these come back and I can open Grasshopper. I could also open it from this icon here because this is Rhino inside of Revit and then this is Grasshopper inside of Revit. Okay, again, speckle issue problem. Okay, I'm going to do the example I did in class again, just as a sort of pre-example. So I'm going to do a curve to link a curve from Rhino, and it has to be this curve. This curve here is to get a curve from Revit. If I was trying to draw a curve in Revit and bring it into Grasshopper, I could use this component here with the kind of gray background. And I had the one with the black background, which is the Rhino native one. And for some people, when they clicked set one curve, that was why, because they were in the wrong curve component. When they would set one curve, it was trying to find something in Revit, not trying to find something in Rhino. It's important to sort of set which direction you're going. So I'm going to just open this sidebar here and make a curve. And I really want to know the units here. So I'm just going to check before I make the curve, do units. And I can see that's in meters. That's fine. So if I draw this too far away from the origin, then I won't see it in here because the origin is in Revit. And if I draw way away from the origin, it will basically be way off the screen. And it's still there in the model, but it's just harder to work with. So I'm going to do a line. I'm going to choose my first point, and I'm going to type it in 0, 0, 0, so that I know that it's like from the origin. And then this is in meters, so I'm going to do, let's say, 10 meters. And I can see now that's locked to the 10 meter distance and 10 meters. And I can just do 10 meters. And that's just on the ground there. And the only reason I'm doing that is so I can scale everything based on that. So if I didn't have that, I might like think this is an okay scale, or that this is an okay scale. Like I just don't know what I'm doing. So I'm just using that curve for scaling so that I know that if I draw this random curve, that I know this is roughly 10 meters by 10 meters. I'm going to set one curve. Just do an extrusion. in the unit's C direction. Okay, so now this appears in Rhino. I'm going to do a slider, not quite 100, it's too big. Okay. So now, because this is Grasshopper open from within Revit, I now have this extra menu. This is not there if you open Rhino the normal way, but direct shape is probably the starting point of any of these kind of workflows, and it's sort of an easy one to work with, but it's not as good as sort of creating things that are native Revit components. So it's a good last resort, and sometimes we do resort to it, but it's sort of an easy way, but not necessarily the most useful if you're in practice and doing sort of advanced workflows of this. So, but it's good to start with. So, and it also just confirms that this process is working and gets us used to how things move. So I can use add direct shape curve to send the curve into Revit. So now that should appear there as a selectable curve in Revit. And I couldn't use the curve to send the extruded surface. I would need the BREP one. There's not a surface one directly. But that sends the BREP. And any updates that I make to these are like a live link. So if I move this slider, that this is being updated in real time. And as we build heavier workflows, this real-time link can get really problematic, especially if the load time to send information from Grasshopper to Revit is 20 seconds or a minute or even 5 minutes. Then every time you make a move, you don't want to wait 5 minutes before you get control back. So it's very common to use triggers with everything. And to set up a trigger, you need to first lock it to say that's going to lock to whatever objects it connects to. And I could do this. And this is just disabling it so that it's not going to do a live link to send information. And that means now if I change this information, it's no longer sending it to Revit until I press play again. And whatever the settings are when I press play, that's the thing. So if I go really tall here, press play, it goes really tall. And then I can bring this back down to something more reasonable. And if I was to count this, so this is currently like an empty container with no top or bottom, and then connect that to that. Again, it's not going to go through because it's locked. Press play. I can see there now this is more solid here because I can't see the edge on the inside. One other issue with this workflow is this is an instruction to create geometry. It's not an instruction to delete geometry. So if I was to delete this, that it says the link is broken, but it also does not delete it from here. So I need to select this. If it's pinned, which depending on the situation it might be, you would need to unpin it with shortcut UP or where my mouse is, this unpin, and then you can delete with either DE or delete. And the curve, because I brought them in separately with a curve direct shape and a BREP direct shape, they were both in there as separate pieces of geometry. So now I'm just going to delete everything that's here and go to bifocals. I'm just going to delete this because I don't need this anymore. And I might go even bigger. Didn't want that to happen. So I'm just giving myself the perspective view only, which is still active. I'm just going to throw this behind. When I minimized it, that wasn't good. So I'm going to start with this canopy project with, say, a rectangle. I need this rectangle with the black line around it. And with that, I can do, because this is in meters, 10.00. I'm just going to make X and Y both 10 for starters. And I can either I can move that rectangle up in the air to sort of begin a roof, or I can do construct point. Oops, not that one. Construct point, this one with the X, Y, Z. And this can be used as a plane. That point, it will just assume that the plane is X, Y, but I can then use this to control the height of where this rectangle is in space. You can see there it moved up, so now it's 3 meters in the air. And then I can do populate 2D. And you could experiment with the same workflow with populate 3D. But this is basically just going to create a bunch of random points inside my rectangle. How many points it's going to create? Whatever is in the count. So let's put that into 100. And move this down to, it's even 10. And because we're going to build a lot of geometry after this, the number of points here is actually going to control how busy everything else that happens afterwards is, because it's all based on how many points are in the model. I can use another 100-point slider to do the seed. And this points is just if I wanted some fixed points to start with, like I already had a structural column grid, and I wanted those points to definitely be included with the model, but then add some random points beyond the starting points. This would be where you just as a point container or a list of points, just put that into the pre-existing point population. It might go a little bit bigger. Go to 20. Okay, and now I'm going to move random numbers in the Z direction. So every single one of these points is going to have a Z factor. And I'm going to do random numbers for the Z vector. And how many random numbers do I need? I want one random number for every point. So the count from how many points there are going inside the population 2D is going to be the same for that. And I might rename this, just to be clear, num points. And this one is a seed value, so I'm just going to put seed. I have another seed here, but this is not going to change the XY position of points. This is just going to change the height. And then for range, this is the maximum height on which the points can move. So at the moment, it's picking random numbers between 0 and 1, which will be between 0 and 1 meter. If I wanted it to be maybe 3 or 4 meters in range, then I would. So this will basically increase the range on which the points can be moved in 3D. If I move this slider, and sorry, it's not connected yet, but that's our random numbers for our unit Z. Let's just turn everything off, Control Q. So if I see this seed, and I might change this to seed XY positions. So you can see this moves where the points are XY, where this one is seed C direction Z. And that just means the points are going to move up and down. They're going to get a random number for where their height is. And this is something we haven't used before this example. It's the Delaunay mesh. And this just takes a bunch of points and tries to make a mesh by making a triangular face with whatever points are the nearest to it. So you can see there, it just makes a very quick mesh pattern. Plane is optional, but we're just, it's fine the way it is. That might be only necessary for a much more complicated example. And then from this, we could use mesh edges. So this is now a mesh, and we're now into the mesh components. This one, we can get the edges, and I might not want naked and interior. I just want the interior edges. So now if you look at what's selected in green, it's just those edges there. I'm going to use these edges to create the beam structure for this canopy. And going back here to the, let's say, the seed value, and then you can see how fast that just changes our design. And this will randomize it even more. So what are the reasons to change the seed is I probably don't like this one connection here, so I might just change the seed value so that preferably that doesn't happen. So that's kind of maybe better. So now these curves, that they can be used to make a structural beam. So we can do add structural beam. And this is similar to the direct shape component in that this is going to connect to Revit, that whenever it goes in here, it's going to actually add stuff to the Revit geometry. So I can see here that I've got within the structures menu or structural, I'm not sure what its full name is. It's either structure or structural. But anyway, add beam system, which is more complicated, but beam, brace, column, and foundations, right? So these are the curves we're going to use, and they're going to go through, and it already creates, without being prompted, something in Revit here, just using its default settings. And it asks me here for type. If I right click, I can sort of select a type. I could choose well, I'm probably not going to change it from the model category, but I can choose structural framing or other things for other components. And then of what structural framing is available, it's these here. These might be slightly different if you use Imperial because it's loading from a different list of options, but mostly the same. And then reference level is kind of connected to what's going on here, so that we've got L1, L2. If I added floor 3, 4, 5, 6, then that would appear here as selectable options. I can also use levels picker, so I don't have to just be dependent on setting it with this right click and sort of selecting an option. I can do level picker. Select L2. And the benefit of this is I can connect this to multiple objects or use it in a more intelligent way so that I can change lots of them all at once and not be, if I right click, I'd have to change them all one by one, especially if you're changing beam systems or something like that. To avoid this right click, I'm going to use two components that are from up here, the components family picker and the element type picker. So this is a long list of everything that's coming from our Revit model. And I need to go down to structural framing. I'm going to pick W because it has the smallest shape, which I'm going to try to pick the smallest for this because it's a very light structure. And then from the input menu as well, this element type picker. And this one doesn't have like an obvious node here. I'm not sure why, but it still just connects like a normal node. And now this is sort of choosing from the list of options that are in the W shapes and gives us a drop-down menu to pick any of these as our beam size. So the smallest one is 150 by 13. And I'm going to see that as our type. and it slightly updated our Revit model. But you can see if I zoom out a little bit here, that now simply by changing this, that Revit should update to pick any one of our beam types. Back to this most. Okay. And then I'm going to put a trigger on this, the same as before, so that it doesn't just always send the updates. I could name these if I wanted beams. Okay. So within more of a Revit method, and this does not display in Rhino. So if I turn this queue on, that this can be seen in Rhino, but this probably can't because it's turned off. I think if it was turned on, yep, but it still wouldn't make a difference. Okay, so within Revit, I can select anything in Revit and look at what the properties are available for it. And there's a whole bunch of different parameters that can be done. Revit is, of course, the shorthand for revise and edit. So that is where you typically create your geometry and then edit its parameters. Rhino and Grasshopper method is probably the other way around, where you edit your parameters and then you create them. So it's sort of flipped there. But so here we create the beam and then we want to change the extension. Now this is in meters. So I could do minus 0.25 here. And same on the end. I can see that that got slightly shorter just right there. Let's go even bigger here, as in minus 0, or let's assume minus 1. Minus 1. Okay, you can see that shrunk that beam way smaller than that. Now I want to shrink all of these beams by 0.25 on both sides, which will be minus 2.5 because I'm shrinking all of them. But I don't want to do that manually. So instead, I need to do something similar to this idea of selecting them, then finding what is the name of the parameter you want to edit, and then editing it. And that's what I'm going to do sort of after I create these beams. And in this way, because we're dealing in Revit, we're kind of doing it where we edit the parameters after we create the geometry, because that's the Revit way. So I think let me just check what menu is in. Query element parameters. I can do Control-Alt. Yeah, so it's in this here. So query element and query element parameters. Those are the that is to check the ID and something. Yeah. So query element parameters, I basically want to take this beam and then change one element's parameter from it. So element parameter. So it's right above it in this element one. Query element parameter and element parameter. So from the beam, that is the element I want to edit. Also from the beam, that is where I want to get the element parameters for. And which parameter do I want to change? That's going to connect to there because this is sort of getting the parameter. But of course, this is blank right now, so I need a name. And its name needs to be copied from here. And if this is capitalized, this needs to be capitalized. If this has a space, this needs a space. If this has a capital on the second letter, this is it. You get it even slightly wrong, it will not work because it's basically needs to match it perfectly. So start extension with capitals matching whatever's written here. And if you change it here, then you have to change it here. It's really looking up what's available in one place and changing it in another place. And if you spell this and you do it wrong, I would just delete all three because they're quite finicky components. And like if I edit this now, it'll probably still be looking for the previous spelling. So that was sort of an issue Madison had. So probably best just, if you don't get it right first time, delete it and start again. And then what value do I want it to be? So the same as I can select this and go to 0. I could change this and make this whatever number I would enter in Revit, I can enter here. So minus 0.25, but I want it negative, so it shrinks it and doesn't expand it. And that is the value. And again, I'm going to do this again. Again, like the same as the messy thing about writing the wrong thing, copying this, in my experience, does not work well. So query element parameters again. I'm just going to not copy paste any of these as I normally would, even though I'm doing the exact same thing. And I want this to be the element for both the query and the change. This will be the parameter I select. Now I can copy a panel because the panel is not going to make any difference. And I want to change start to end, so it's from the other side. I'll give it the name. And then I can use this panel for both values of how much I shrink the end and how much I shrink to the side. And then I can basically just connect, I think I might just connect everything to the trigger, so it sort of launches everything to reload all at once. Now I'm going to press play and see, hopefully this works if it was connected right. And as I said, if this doesn't work, I would just delete everything from here and restart. And what we're looking for, so it worked. If I hold on shift to turn around here, looking that it shrinks all of these beams so they're not intersecting on both sides of it. So it's, if I left click it, I can see here that now it's got the start extension minus 0.25 and minus 0.25. That means it worked. Just to sort of further confirm it's working, if I change this to shrink it by 7, and then I press play, all of these should shrink, every single one of them. So I'm going to put it back to 2.5. That's what I actually want it to be. And that's the beam part complete, which is where we got to in the first class. So I might just make some groups and put I might drag this from where I did to get the interior edges and make this all into a group and just call it beams. I much prefer just for these groups to be, whoops. Which is not using my default settings because the Rhino is loaded from a different place. So I make it white and then color default. Okay. So now from this mesh, I want to get positions to do columns from, and I basically want these. So I'm going to deconstruct the mesh. And that will give me vertices. That's the green points selected there. Now from the green points selected, I'm going to bring these down here, say. This is going to be my next columns part. So with these vertices selected, I can project them to the C-plane, or I can deconstruct the point. So So this is project onto a plane. This is, I think this one should just go to the C. Well, the C plane should be the default one. Yeah, that just goes to the ground. A different way that I've done it before is to deconstruct the points and construct the points. And basically from the data, if you look at all the data, I just want to keep the X, keep the Y, and move the Z to 0. So you can see that brings it down. And the nice thing about this method is I could, for example, put a slider in here, and then this would control what height they're going down. I'm just controlling the Z value on every single one of these points, rewriting all the points, saying keep your original XY value, but your Z value, I'm going to rewrite that as 0. You can use either method. So with these points on the ground here and the ones in the air, I can create a line, just as we've done before. And the start point, I might make the ground point, because the Revit likes to draw things in that order. And even though I'm not sure, we'll check out how it works. But so there's a line that way. And even though those 2 points are there, I sometimes just add this component there because I'm lazy, and now the 2 points will be kind of linked at the end in case I need them. And I think I might need the length of these lines. So that's what columns require. So we have the start point, the end point, and the length, in case whatever we need. So now I can see that if I go to create a column, so add column, add structural column, we'll just do a regular column. If we just add structural column, it kind of gives it so it's selecting from a different set of pre-created columns in Revit. And it also asks us for slightly different, where it wants to be defined by base level and top level, where this just wants to be defined by a level constraint, a number, an elevation. It has a lot more freedom. This would have to have more complicated levels. So let's use column. So the location the column wants to be located, I'm almost sure that's going to be our start point. And then the top in this case can be a length, so that can be there. And then type, similar to before, it's selecting so because I selected the length, that's why all our columns are going to up to the exact right point there. You can see what's happening here as well. So the height is being set in this one here. So that's a column for every single point. And I might not want a column on every single point. So I might go back a bit to the vertices and move all of this stuff forward. And let's do deconstruct point. Sort all of the list of the Z values. And this will, keys will basically sort all these numbers. So that's just these numbers here from the Z values sorted there. But I want to match the pattern to sort the points by the same sorting pattern as the way that the Z values were sorted. So these points, values A here, should be sorted. So if I do a split list, which I can set the index to split, like kind of when a magician asks you to divide a pack of cards, you can say divide at a number. So let's do regular point, not Revit point. So if I look at what's going on here, and I turn this down. So this here is the 7 points which are the lowest C value. So now I might use these points instead of all of the points. So this is all points, but I might change this to here and this to the end. Now, I wasn't sure if Revit would actually update in terms of would it keep some of the old geometry there. And that's what I meant about deleting stuff. It appears to, in this case, have worked pretty well. So that's fine. And I can just check. I will see. So I can increase in Revit how many points I'm taking. So it's definitely going to leave out some of the biggest ones. And I'm just curious if it actually removes them. Oh, it does. Okay, that's nice. Yeah, I think you need to keep an eye out, though, in case Revit does or does not remove things when you want them removed. In this case, it does. Okay. And here we did where we changed the length of the line in Revit by editing the parameters. If we were to, by comparison, do it in Grasshopper, it's a lot easier. So in this case, of all the length values, before you create the geometry, so this is we're on this side of the column, not after, subtract in meters, let's say anything between 0 and 2 meters. No way we're going to subtract 2, but it's 6 small. So this is going to subtract this number from all of the numbers and then give that as the length. So if I increase from the top how much I'm subtracting, I can bring those columns all down, leaving kind of a gap there. And later we're going to create this kind of complicated bit there. Good. So I also want a trigger on this. Lock the trigger there. And then I can put a group around this and just call it columns. So this next part is probably the more challenging one, especially for Revit users or native Revit users. And it's the idea of you can't get a sort of off-the-shelf part from Home Depot or wherever to actually fit this. You can get, from construction industry, I-beams of a certain size and then on-site cut them or have them professionally cut to give you different sizes. But getting all these nodes that line up to these random angles that when we move a slider is going to randomize them even further, that's more where every single one of these nodes would need to be custom made and custom designed. At least for this. So to do that, I'm going to do it mostly in Grasshopper, and I'm going to use the interior edges again. I'm just going to copy this node and bring it down here. So my starting point here is so this is the mesh edges that I copied from the beams one. So I can see what I'm selecting here in Rhino. So again, I'm going to just use the interior edges because that's what I used above. And I guess one thing I have to be aware of is if the columns are actually only connected to the exterior edges. And like if we wanted to use both, we would just put them both through there and then update the beams. So it should create new beams for our outside. Yeah, there we go. See, these two beams are new. All right, we'll do that. So now it kind of has more of the square beginning that it had. Okay, so I guess we'll use both naked and interior edges. So the random way of doing what I did above would be just to take all these curves and 0 to 5. I could create it there. What I probably should do, just so that they are only ever changed in one place, is take this from here and bring it down to here. So this is the 0 to 5. That means if I change it in one place, it will change it in all places. Just make a relay. Okay, so now I might just do wire display hidden. So now it's got like wireless connections up to the where that's being changed at the top. And you can see here that these curves are shrunk 0.25 on either end. So if I had connected this to the beam, this would have been all I needed. And this would probably have been a more efficient way to do it in Rhino in Grasshopper than in Revit. But the only reason I did it the Revit way is just to show you how you query an element parameter and then change an element parameter. So in all practice and real world stuff, I would have done it this way. So of these curves here, I'm really looking for not these curves, I'm looking for these curves here. And this is more of a workaround of how I get, there's so many different ways in Grasshopper you could get those curves as opposed to these curves. So I'm going to do the endpoints of all the curves that have been shrunk. And I'm going to do all the endpoints of the curves that haven't been shrunk. And then I'm going to create lines from the start point of the regular line to the start point of the shrunk line. And that's basically from, let's say, the regular line to the shrunk line. And it's basically going to give me those endpoints. And then also from the end to the end, which is going to give me the other side of it. And I don't really care that this is sort of the start of, these are part of the start of these curves that are selected, and these are part of the end of there. It really doesn't matter. I just wanted all the curves in this one area. So I'm going to do merge. And then they just become one flattened list of curves to the 100 curves total. And I'm going to get the middle of all of them. Midpoint. Okay. So I'm trying to build these like little nodes to connect all these beams together, basically. And I've got these points now, and I've got my lines here. Now, quite similar to the Delaunay mesh is a proximity 3D component. And if I just do Control-Alt to see where this comes from, so it's from the mesh here from triangulation. So here's proximity 3D, and here's Delaunay mesh. These are both forms of mesh triangulation. And in this case, I need these points here. And I want to connect all the points, but it's currently trying to connect 5 points together, which this is going to be a random number, so I might make that higher. But currently, if I go higher, so in this case, I want to connect 1, 2, 3, 4, 5, 6. In some cases, depending on how many connections, it's going to get the 7 closest points to it. So it's going to make these long leaps like that. So I want to make the maximum radius, which again is in meters. So I might just say the maximum you can go is 1 meter, and then turn it down if that doesn't work. Oh, that worked. It sort of said, so now basically grab up to 7 points, but don't go further than a meter. If I thought I was going to need it on slightly different settings, it was slightly bigger. Maybe because I have less points in this, because I was making sure it goes fast. So if 3.2 was the maximum radius, then it's going to get up to 7 points that are within 3 meters of its original point, of every point. And it's like every point trying to connect to 7 other points, which is why we get this sort of network thing going on. But just in case I use more points, I might bring this down to about 0.85 of a meter. Now I've got all my little clusters, and they are exported here. If I just do a panel, so there are lines from every point to 7 closest points, or up to 7 closest points. And this is topology, which is the index numbers that it's connected to. So it's like point number 99 is connected to point 53. Okay, so now I can do list item and use those index numbers, this topology here, as my index. So that's my ones that I want to grab. I think from that, I'm trying to grab this list here. So this here, I select this here. This is all of the lines that are in these nodes. So that's 100 curves there. See, it's 100 lines, but there's no data structure. It's just 100 lines as a flat list. But I look at what's going on here, and now I have these numbers grabbing the list of curves from that list of 100. So it's saying basically curve number 1432, put them all on a branch together because they're in one of these clusters together. Then curve 0432, put them in a cluster as well. And so on. Hopefully this is working the way I want it to work. Just go on to the next step. Let's see this one. So now I can do a multi-pipe and see if these groups are working. So multi-pipe will apply to each group individually. So I want to do multi-pipe. Before I connect it, given this is usually quite a heavy component, the node size is quite important. So I might, and knowing that it's in meters, I might make it 0.05. And that's the thickness of the pipe, so that when I connect this, it seemed to work. So basically connecting and making these shapes here. So from the original lines in the groups that they're in, and this whole process is just about creating those groups. It's actually kind of a complicated way of doing it, but it's it works. So So now I can see that it creates all of this. Now getting a sub D, because that's what the output of here, to Revit is probably more harder. So I might do convert the sub D to a mesh with sub D to mesh. Sub D from mesh, or say mesh from sub D, the other way around. And then I might turn all this stuff off anymore. And I could change this caps to round or flat. I might do flat. So that puts the solid thing on the edge here. And now that this is a mesh, I might just use a direct shape for this one. So Revit, direct shape, mesh. And now it's bringing all of those connections in. We come in here as direct shapes, which are like our custom nodes. If we wanted to go one step further, we could take a point at the top of these columns. Let me just check curve commit plane. Probably need it in here. So let me just turn this off and check. Okay, so so these lines, this is how much I did the extend shrink on them. So let's just do, firstly, make this into a group and move it down. So I kind of really did it into a group so that I can move it down all at one go. And from this line here, I might do extend where I really want to shrink the curve, but extend, and then I can either do the entire length of the curve minus this amount. So let's just start with 100 to see which end is which end. I presume it's the so with this selected, if I go off the end point here, okay, so I can see from the bottom that they're getting smaller with that one. And they're getting smaller from the... So this needs to go to end. Sorry, this should have been 0. That's why it was sort of extending right at the bottom, which was confusing. Okay, so that's going to be slightly smaller than this one. So double check this again. Oh, yeah, it needs to be negative. Yeah, so now I can see that it's shrinking there. Perfect. Okay, so this goes to here. Or alternatively, which is maybe, because now I have to get the way of trimming that. As an alternative, what I really want to do is take the length of the line, whatever the whole length is, subtract this number, so this is the total height, and delete that from the start and actually leave the end as 0. So I'm going to make the to end 0 and do that for the start line. Now that works. No. Oh, did I delete the negative again? Sorry, I meant to keep the negative. So take the length of the new line, make that the negative. Yeah, and now I just have this top part here to the top of the column. So that's basically from there to there. Sorry, made a mess of this. And I can put that into my merge as well. And go a +1 here to the top. And now I think that might have messed things up. Yeah, let's flatten this. There we go. So now my components are going down to meet if there is a column, and if there's not a column, none of them are appearing because there's no column there. So it's all connected. And I can just do, let's say, shaded. There we go. And that is the example in class. I'm going to do a quick image after this video of what a more complicated version might look like. And if you want to do that for the sort of the A answer, and you can sort of pick between the regular answer or the A answer, what you want to submit on Miro. All right. See you in class.